meeting is being recorded.
Hello, everybody. Today we're just going to go over the Allegro board import capabilities that are native to ADS. There's several methods to get Cadence Allegro board designs into ADS. We have a classic ADFI flow, which allows you to do a lot of the pin port assignment, cookie cutting all from the Allegro side. For folks that don't have a Cadence Allegro installation that's licensed, we also have a direct board import capability that's been shipping with the last few releases of ADS, and we'll review that flow today. So I'm starting off with ADS 2020 Update 1. I'm going to go ahead and create a new workspace, give it an intelligent design name here. Allegro board import. Create workspace. Okay, we're almost ready to import. But before we do, I want to make sure you realize it's important to have the Cadence Allegro install package installed on your machine. So I have both 17.2 and 16.6 on mine. Either should work. It doesn't need to be licensed. It just needs to be installed on your machine so we can use the extractor module that is included with that installation. So if that's included, we basically just go ahead here and say File, Import Design, and we'll select the Allegro board file. I have an example board here in my temp directory, this AGC proto board. I've already browsed to here. Just hit OK. There's going to be a warning here about using net-based connectivity settings. This is important for our signal integrity design flows, which are very much net-based in terms of defining what is EM simulated. We have another flow RF Pro, which we'll introduce as well, that can use net-based flow here as well. We're not going to worry about it. We will be selecting the area of interest and assigning pins. But just hit yes, allow that to go forward. Within a short period of time, hopefully you'll see your board come in. And after the board comes in, we have a folder with all the components called out here that are mounted onto the board, as well as a layout. And in this layout file here, we can see, we can inspect the board, hit the 3 key. It's a new feature in ADS. We can go and examine in 3 dimensions and see that this is a 4-layer board with coplanar waveguide structures on the top. We're really just going to focus on this RF through trace here for analysis today. But we also have the substrate stack up. We can open up the substrate stack up editor here. We can see that the board has been brought over. Within this editor, we have a lot of cool features as well. Say we were trying to reconsider that coplanar waveguide design. You could launch the controlled impedance line designer from this menu. Go ahead and say select coplanar waveguide single-ended. Set some realistic widths here, do some analysis, see what kind of impedance your CPW line might have. Possibly you want to optimize that line, so we could optimize the clearance for a 50 ohm impedance and quickly come up with a transmission line recipe if we wanted to redesign this. We can save line types away afterwards, so you can use those in schematic simulations. So yeah, you have access to these tools, this controlled impedance line designer, and it's all part of our interconnect toolbox. This VIA designer is also part of that. So it allows you to get both those transmission lines and the vias designed appropriately for your system. You can go in and add different layers, different kind of feeds, coaxial feeds, microstrip feeds in this case. You can do differential vias and run simulations and get models for your vias to use in your top level schematic simulation in ADS. Anyways, we'll close that out and save more details for that for another day. But while we have the substrate editor open here, we're going to want to simulate some traces on the top. We know they're fairly well grounded with HL2. We don't want to bother simulating the rest of the substrate stack up. So we're going to play a few tricks. We're going to insert a cover below so we have an ideal ground. We will delete some of these other substrate layers that aren't needed. So we're deleting with the upper interface. And then that just leaves what we need for simulation. In general, when doing these imports, you want to make sure that copper or whatever is assigned is the materials, the thicknesses are right, make sure everything came over properly, make sure your CAD engineer didn't get lazy about documenting some of the dimensions and material properties and such. Anyways, we're going to use this as a modified substrate. So I'm going to say save as cover. So this will be our simplified substrate for running some of our first EM simulations. Hit X. So the next thing we probably want to do here is make a cookie cut of our board. We don't want to simulate the rest of the board. We're really just interested in the through path. There's several methods to do cookie cuts. You could select that trace here, RF through. You could go into EM, Tools, Cookie Cutter, and you could choose to do a convex hull around that trace if you like. You can look at the preview, see what kind of resultant shape you'll have. I'm not going to use this menu. I'm actually going to do it a little differently. I'm going to use our layout command line reference. This is an extra add-on from ADS, from the ADS main window. You go in here and say Tools, Apps Manager, and make sure this layout command line editor is enabled. If it's not, click it off. It'll tell you that you need to restart ADS for it to work. You should be able to restart ADS and make it work after that. Along with this command line, if you just want to know here, you right-click over here. You can turn this guy off. In case you don't see it, you want to right-click into this area, make sure you turn out layout command line, make sure it's enabled. But there's a nice reference book that you can look at here to see what the different commands are. I like using delta X, delta Y, CX, CY for doing precise moves and copy and pastes rather than just grabbing things and dragging it with the mouse. That's not a good habit. We're going to use CC as a cookie cut command today. I'd encourage you to look at this reference manual and see all the other handy commands you can apply here. But so to do this, we're just going to go ahead and use some kind of cutting layer. I'm going to grab a layer that's not involved in the actual board technology, one of the ADS standard layers here, a label layer. But I'll go ahead and select that and hit CC, enter, boom. So now we have our cookie cut of our board, but realize it's still the original board import. You want to save as something different so you don't lose the original board. So I'm just going to call this through. It's a smaller board to run our simulations on. Okay, next we're going to add a couple pins to create some ports. So I'll drop a pin down on the input side. I'd like to visualize the pin sourcing into the transmission line, even though it really doesn't matter in our momentum simulator. It really only matters in our FEM simulator, but it's more just a visual thing. So port 2. Okay, so we have our ports supplied. We do have a default substrate it's looking at right now, which is that original substrate, not the modified one. We'll get back to that soon. But let's just go ahead and run this in our RF Pro tool first, just as an example. We go Tools of that flow, an example of the RF Pro flow. Go into Tools, New, and this time I'm going to make sure that I'm selecting the substrate with the cover. So I'm using a simplified substrate. Hit OK, hit Save. This should launch the design into our RF Pro GUI. Those that have used EM Pro in the past might recognize this as a familiar GUI. It's very similar, and our new SI Pro, PI Pro tools as well use a similar GUI here. So once you learn it, it's easy for you to consider the other pros offerings for different design flows. So anyways, we'll focus on our Pro design flow for the moment. We have the design in. You can go ahead, open this, and say, okay, click on the pins. We're going to do a user-defined EM analysis. I'll drag those pins down to the port menu. I open these guys. I find that the tool is intelligent enough to know that the negative pin for this port is going to be on the cover. So port 1 is using a reference on the cover. Port 2 is using a reference on the cover. As well, it knows that those ports are connected to RF through, so it's brought that net over. From here, we could literally just hit the simulate button and run it. But let's just review some options real quick. So we're going to go from 0 to 10 gigahertz. We're going to go to the simulator. We're going to choose RF momentum mode. We could do microwave or FEM as well. As you click on those different personalities, you'll see this advanced tab change with the different options that can be selected. I'm just going to go with the defaults for this demonstration. We could run multiple threads if you want to run parallel jobs and such. You can put some notes in here if you like for documentation purposes. Set done and run and let this guy go. Okay, simulation finished. It's complete. So we can go over here now and you can look in the results, look at your S parameters that we simulated. You can do a lot of things. You can go in here and look under your TDR. menu and come back and see what kind of impedance that line is really presenting. It's a little bit higher than 50 ohms. We probably will make some changes. Anyways, we'll save that for a future video. So if we're happy with that EM model, things seem to simulate the way they want, the way we want them to. We can generate a few things. We can generate a test bench, so you can just simulate those S parameters directly here. This is the S parameter block. Things are wired out to ports for you. You can also generate a subcircuit. So this subcircuit has everything minus the S parameter simulation controller and the ports, but it's basically just wiring out those S parameter ports to some sensible locations for you to have a symbol here. So you can have just a simple symbol view to run at a top level simulation in ADS. Anyways, so that's RF Pro Flow. I'll go back, close that, might as well save my changes, sure. Let's go ahead and just do a quick momentum simulation. So I'll open up that layout, save it as a different name. You can do this at the cell view as well. Just want an extension of momentum. Okay, so we're going to have to create an EM setup. So we're going to click on this EM setup thing here, and it's going to say, hey, what do you want to do? You want to use a template? Yeah, I'm going to use the supplied RF board template. There's Mimic, there's module, antenna, but in this case, we're really analyzing a board. So let's go with the RF board EM setup template. This opens. We're selecting, again, RF mode for our simulator. We can check our ports. These are ground reference ports, but we got to make sure we pick the right substrate. So we are using this modified substrate here with cover. So that's going to make sure that these ports are going to reference themselves on the cover. Set a frequency range. Under options, we might want to check a few things. The solver's been set for the direct dense matrix solve method, a bit more robust and more accurate at higher frequencies. That comes along with that RF board template setting, as do many of the other settings in here. We're using a sheet for the thick conductor. We could use a 2D or 3D distributed model if we were more worried about the sidewall currents. For quick simulation, I'm just going to keep this for sheet. It can be important to go ahead and create yourself an EM symbol, so that later on you can access that. And if you want to start doing sweeps, you can build a database of different EM models within. Anyways, we'll let that go. I could click simulate right now, but first I always like to encourage people to look at the 3D EM preview of your design. You click on this green cube here. It might take a little bit for it to launch. You can look at the cog down here and see that this thing's running. It's actually rendering a graphic at this stage.
This meeting is being recorded.
Okay, and so after that graphic renders itself, you should see a view of your board with the EM simplifications that are being applied. You can see the vias are now hexagonal, as the arc resolution was set for 30 degrees, I believe, in this case. You can see the ports finding their ground reference to the cover here. You can check a few things, click the ohm meter, verify some connectivity in here. We can look at the trace and see it's going from one side to the other. Not very interesting, but if you had multiple traces, you might want to check them to see how things are connecting up. You can click on the adjacent ground plane and see it map its way through the vias, through the cover, back up through the vias to the other side to verify that you do have the ground connection you believe you have. Again, just a good thing I encourage folks to do before you hit simulate. You might have to wait a little less longer for things to fail if something's wrong. But I'll go ahead and click the simulate button and let that go.
This meeting is being recorded.
Okay, the simulation's running along here. It should be concluding fairly soon. We're doing an adaptive frequency sweep. As soon as it has enough data points in here, it can predict S parameter behavior. Okay, here we go. Simulation finished. Some S parameters to look at, similar as in RF Pro. Save the changes. Okay. So we can come back and check our mesh and our layout. After that simulation completes, you could run this mesh before simulation if you wanted to. I'm going to clear that. I just don't have to look at it in layout. Okay, well, what else? So let's go back to the ADS main window here. So we just ran that momentum analysis. We do have an EM model here. Within the EM model, you can see there's a database. In case you want to check that database, you can go click on it and create a data display and generate those plots again, just to verify you're looking at what you think you're looking at. Save at that time. So let's go ahead and use that. We probably want to create some kind of top-level simulation and use the model. So let's go ahead and first we'll create a S-parameter top-level test bench, create schematic. We can be lazy and insert one of our templates here to set up an S-parameter simulation for us. I'll scroll down to S-parameter example, drop that in. So we have a couple ports. We have a simulation controller and a data display template all ready to go. We want to create a symbol for that momentum simulation. So in RF Pro, we created a symbol here, more of a black box. You could use that. I'm going to show you how to create a layout lookalike. So we can go into this momentum simulation. We can go to Window, Symbol. There's always a few different ways you can do things in ADS. We could also do this from the workspace tree by clicking on the cell and saying New Symbol. But we'll go ahead, we'll create a symbol under that cell, and we're going to do a layout lookalike. So we have this menu pick here. We have a layout. The tool recognizes that. It's going to do a lookalike for us. We could do symbol types as well. We'll create one symbol pin per EM port, and then we need to try one of these different methods to set the scaling or the size of the pins relative to the artwork. I'm going to set this guy for 0.01, hit apply, and I can see here, okay, the size of that pin is pretty good size. It's going to be easy to grab in a schematic relevant to the artwork. So I'll hit OK, hit save. So now I have that symbol view. So now what we can do is in our top level schematic here, our test bench, we can use the insert key, or you can drag it from the workspace if you prefer. From the workspace tree, you can drag it on over. I'll go down here and select that guy, drop him in. This is our lookalike that we just created. You can come on over and wire it up to our supports and go ahead and hit the simulate button. And voila, we have our S parameters again. Just as an FYI, from the data display window here, when you have an S parameter data set, you can use the data file tool to export away your S parameters. Your colleague, if you want to send it over to them, if say they're not using one of our tools, they can go ahead and take advantage of that and write a data set off. Now that'll be available in your data file or folder of your workspace, so send that off. Addition, we have front panel tool here. It's interesting if you want to get back to some of that TDR. Understanding of your board, you can go in here and select what data set you're trying to simulate and drag that over. Actually, that guy. And we might get some warnings about frequency range, making sure we have enough frequency coverage. This was running from, I believe, 1 gigahertz to 10, so we do not. I'd want to rerun that down to DC to get an accurate profile of the impedance. We can probably do that pretty quickly. Come back over in here, set that for 0. Go ahead and simulate one more time. And we'll go back to that menu. We'll select the data, and now we can go ahead and scrutinize the impedance. It's important to make sure you have a sharp enough of an edge. So often I might reduce this rise time down to say 10 picoseconds in this case. Make sure things aren't changing too much when I go back and look at this profile here. Again, north of 50 ohms, we could design this line better. Okay, thank you very much. Hope that wasn't too much information for a 20-minute video, and I hope the audio came out better this time. Take care.